Hey, hello everyone and welcome in a new video. In this video, I'd like to show you how to create a bridge and to create some namespaces like Docker do. This is the purpose of this video. So before, if you want to not miss the next video, you can subscribe to the channel. If you want to find the code that we use in this video, you can open the description of this video under this video and behind this video, and you can click on the link, follow the link, git clone and enjoy. So let's go. What is a bridge before? A bridge, if you see my screen, the bridge, for example, here we have a bridge that the bridge we will create in this video, Xavkey 0, and the bridge allows us to use a physical interface, not only a real physical interface. For example, we use a virtual machine, and of course ETH1 is a virtual Ethernet interface. So in this case, we create the bridge Xavkey 0, and this bridge allows us to work like a switch. If you know what is it, a switch allows us to mount a physical interface like ETH1 and create under this bridge some virtual interface. For example, like in our video, we will create XPR1 and XPR2. And in this video, we like to isolate each network or part of network like a Docker container with network namespace. Network namespace, in our case, we have one network namespace x1 and another network namespace x2, and only in this namespace we can use XPR1 or XPR2. This is like we use Docker and just see only the network namespace functionality. And of course, to use this bridge and to connect this bridge with our virtual interface, XPR1 or XPR2, we need to have a wire to connect XPR1 between with Xavkey 0, and to do it, we need to create a virtual wire, for example, ETH1 and ETH2. So now let's go. We can open a terminal. We haven't Docker installed on our virtual server. And if we check right now how many interfaces that we have on our server, you can forget ETH0 because this is dedicated to Vagrant. We have only the loopback, so 127.0.0.1. This is not the same local host that we will use into our namespace, because if we just open this diagram, we have a localhost for our virtual machine. So okay, but remember, when we use a container, we have a dedicated localhost into our namespaces like x1, and so we have a localhost here and here, and we need of course to have a localhost, and we need to add an IP, a virtual IP for XPR1 or XPR2. So let's go. In our case, we want to mount our bridge on a virtual Ethernet interface, ETH1, but it's possible to use this case for a physical interface. No change. Let's go for the code. This is a script, but we can. I prefer to take one line by one line. First part, we need to set some variable to avoid to insert the same data many times into our command line. What we set the name of our namespace. The name of the variable for namespace 1 is ns1 and the value x1, and for the second namespace ns2 for x2. So we have x1 and x2 here, and for the wire we set vETH1 and vETH2 with the value xETH1 and xETH2, and for the interface into our namespace, for our namespaces, because we have two namespaces, vPeer1 and vPeer2 with xPeer1, xPeer2, and now we want to have for x virtual interface in our for our namespace, we want to have two addresses, vPeer ADDR1 and ADDR2 here in the same network for 10.11.0.10 and the second 10.11.0.20. Okay, and of course we need and we want to have a bridge, and our bridge, the name of our bridge is the variable br underscore dev for the value xavkey 0, and for our bridge we need to have an IP here, so here, and we have the common IP, of course. This is we connect two wires on the same interface of our bridge, and this IP we need to have this IP into the same network, and we use 10.11.0.1, so we have only 3 IP reserved into our network. So let's go to define these variables. So I just want to be root before to be sure that easy and quickly to do it. And the first thing I want to do is to create our namespace. So I use this command line ipnetns. Ipnetns is a command line to manage our namespaces. So I use ipnetns add, and the first variable for our first namespace and the second namespace. So I use it here, and if I remember well, I can use ipnetns ls, and now I have two namespaces, x2 and x1. Okay, this is the first step. Now, what I want to do, I want to create two vEthernet and plug it to interfaces. So this is like we create wire, two wires, and connect it to vPeer1 and vPeer2. vPeer1 and vPeer2 is only, if I check here, this connection. This is, we create this wire and we create here vPeer1 vpeer1 with the name xpeer1. So I create it, and vpeer1 is the name of our interface, and sorry, xpeer1 is the name of our interface, and xpeer2 is the name of the second interface for the second namespace. Okay, it's done, and now I check just here. Now I can find here xpeer1, okay, and xpeer2. You can see it here, so it's pretty good. And sorry, yes, yes, it's okay. And now if I check what we do, we add here, we add interfaces into we set our vpeer1. So this is the new interfaces. vpeer1 is xpeer1 and xpeer2 into each namespace. So this is now where we create our isolation layer. So we allocate xpeer1 to each namespace. So we allocate xpeer1 to x1 namespace and xpeer2 to x2 namespace. So to do it, I copy these lines, IP link set the name of our interface and the namespace where we want to allocate it. Let's go, apply, okay, it seems to be good. So now what I want to do, I want to activate each veth1, it's the link, it's here our, sorry, veth1, it's our wire, so we want to activate our wire here. So to do it, we use IP link set up, because for now it's our interface, our wire is down. If we check maybe here, yes, you can find here each element is down. So now if I check, sorry, we can see all element is not done. Look, it seems to be okay, and we can check here the link was done with x1 and x2 for each wire, okay, virtual wire, of course. So now what we want to do, this is a plug, this is here, we are up, okay, and now we can check the namespace. So we can do it one by one. So if I check, if I go into namespace to check what we have right now, we have, when I use the first namespace, so x1, and I want to use IPA command line, but in the context of our network namespace, x1, I can use this command IP netns, the name of our network, and A. So if I do it, what I have a loopback, but this is not the loopback, the same loopback like I am into our virtual server. This is a loopback into our namespace. And if I do the same, if I check, I have a second interface here. This is xpeer1. xpeer1 is here, and we are here, so we have our loopback and xpeer1. And when we use IP command line with --netns and the name of our namespace, this is like if we are isolated into our dedicated namespace. Okay, I can do the same command line with the namespace 2, x2, and I have, of course, the same result with an output with our loopback and xpeer2 because we are in the second namespace. Okay, so now we want to activate, of course, our interface. If we check here, if we check, for example, xpeer2, we can find the state here, and the state is down for xpeer2, but the same output for the loopback, the state is the same with the state down. We want to activate in each namespace the loopback and the interface. So to do it, first for the loopback, what I do, I go into, I want to run an IP link set LO for loopback into loopback up, but we want to exec IP link set LO up only in our namespace, in the network namespace of namespace 1 and of namespace 2. So to do it, we just prefix all the command line IP link set with a first IP netns exec and the name of the namespace 1 on the namespace 2 when we want to activate the loopback. So if I do it and I check just after, if I go, for example, in the network namespace ns2, x2, and if I check now, we just activate, the state is not down, we activate the loopback, and now in our network namespace we have, we can ping our loopback. So we need to do the same things with each interface in each network namespace. So to do it, I use same command line. So at each time we run two command line. The first for the first namespace here, IP netns exec in the context of our namespace 1, and I want an IP link set up again, but on the vpeer1 xpeer1, and the same for xpeer2 in the namespace 2. So I do it. Okay, if I check again here with IP netns ns2, I have here an xpeer2 interface with the state up. Okay, but not if you can note that we haven't any IP for this interface, so we need to attribute, to allocate, and to set our IP on this interface. So to do it, what we can do, we can do, for example, in the namespace 1, we can attach or set our IP on this interface with always IP netns exec and our network namespace ns1, and we want now to add an IP on xpeer1, so we just run the command in this context, IP addr add, and the vpeer addr1 address, this is our address, 10.11.0.10, if I remember when, the slash here slash 16, for example, this is just an example, and the device where we want to plug this IP. Of course, this device is, for example, in our first network namespace, x1, this is, of course, xpeer1. So let's go. If I check for xpeer1 here, we have xpeer1, and now, of course, we have our IP on our interface. So we can do the same thing on the second namespace. Okay, so let's go. I'm gonna change only 1 to pass to 2, and I run. Oh no, this is not on vpr1 but on vpr2. Okay, and I can check. I'm gonna check IPA into our network namespace, and we have here 10.11.0.20. Okay. So now we need to set our bridge. First thing that we can do is to create our bridge. To do it, we use the command line ip-link add, the name of our bridge, and type bridge. Okay, so I use it not in a network namespace. And okay, if I check here, we have now I think that key 0, but the state is down, and now we need, of course, to activate it. So ip-link, set the name of our bridge with key 0, and now I'm gonna to check again IPA, and it seems to be okay, but we need to add, of course, an IP on this network, on this bridge, sorry. So to do it, we need before to allocate our IP on this bridge, we need to connect the second part of each wire. The first part was to plug it on xpeer1 or xpeer2 for XETH1 and 2. And now we need to connect the other part here on our bridge and here on our bridge. So to do it, I run this command line to tell that we want to connect this is our variable for XETH1 master on the bridge with key 0, and the same on here for XETH2. Okay, and now we can attribute here our IP of our bridge. So this is 10.11.0.1 in our case, but you can set 2 or what you want. Okay, and now I can check my bridge in IPA, and we have our IP here. Okay, it seems to be good. Now what we want to do, we want to define in our namespace each default route. Of course, if we want to check before, if I just copy this part of line, if I run IPR to list each route into our network namespace, for example in X1, I just have this route, of course, but I don't have any route, default route. This is not really current, and we need to define our default route. To do it, in the context of our namespace, I want to run IP route add to add a route named default, and via our bridge with key 0. So I run it, and now if I check again, I have a second route. This is our default route. Okay, so now if we want to communicate to an external IP of our IP in this namespace, I need to pass by our XavKey0 bridge, for example, to go to the second container. If we consider that this, x1 and x2 is are a container, and so now I can just do the same thing into our second namespace here, okay. And if I check again my routes into NS2, I have same route, okay. It seems to be good. And what we want to do now, so before I can check something, so I want to check if I can communicate with my bridge, for example, XavKey0, from our second network namespace. For example, I can ping 10.11.0.1. This is our bridge. If I check it, it works. Okay. So far so good for now. And if I want to check if I can send a ping to our first namespace. I can ping here the XPR1 IP. So this is a 10.11.0.10. Remember, we use default route in this case. So we start from the 10.11.0.20 network namespace. If I just simplify the use case, and I transfer it to our bridge, XavKey0, and our bridge transfer it to our first network namespace. So let's go, and we can ping again our first network namespace. So, but if I check, I'm gonna ping 8.8.8.8. This is the DNS of Google. If I check, I can't. Okay, so why? Because we want to forward all what we want to transfer outside of our bridge. So to do it, what we need to do, the first thing that we need to do is to activate the IP forward on our virtual server. Okay, so I do it with just one command. And the second element that we need to do is to activate the post routing. This is to tell that all traffic need to pass by our bridge. If this is not an IP managed by into our bridge, for example, the IP of the bridge or the IP of namespace 1, 2, 3, and so on, don't need to go outside of our bridge. So this is why we have here a not element into IP tables to tell that not in the case where we are in our bridge. So we use a post routing to do a NAT to ensure that this traffic can go outside of our bridge and can go back. So to do it, I set IP tables NAT rule, sorry, with the post routing, and the post routing with the source from our bridge network, not only the IP, this is the /16, and not if the source, not the source, the destination go into the bridge. So let's go. And if I check again here, now we can ping because we can go outside of our bridge with our into our network namespace. And if you use Docker, because here I haven't any Docker installed, but if you have Docker on the same server, you need to whitelist or to allow the forwarding like this. Dedicated IP table rule with a forward one. One is the order, and when the destination or the source is in our range, we need and we want to ensure that we can accept this traffic. So we can do it that don't change anything in our case because we don't have Docker, but that don't change anything, and it's okay. That's it for today. Do not miss the next video, so subscribe to it, and see you then. Bye.